Blockchain is something that a lot of people are curious about, but also confused. You hear a lot of success stories of how people earn money with mining and terms like decentralized and distributed, but what does all of this really mean? Hello world, my name is Monis and today I'm going to break down blockchain technology in the simplest way possible. No technical jargon, no complex theories, just a clear and straightforward explanation of what exactly is blockchain and how it works in plain simple language. We will also cover the basics of how transactions work in blockchain and understand the concept of mining, how it works, and how people make money from it. So without further ado, let's get started and demystify the blockchain technology. Think of a bank. Every time you make a transaction, whether you're buying something or transferring money, it gets recorded in your bank statement. Each line in that statement represents a transaction, either a debit or a credit. Once this transaction is recorded, it cannot be changed or deleted. This makes each transaction in your statement immutable. All these transactions are stored in your bank's database, forming what is known as a ledger. Essentially, a ledger is a record of transactions that includes all details like the amount, the date, the type of transaction, and a unique transaction ID. In the context of a bank, the bank maintains a general ledger which has a list of all transactions of all bank accounts. This is visible only to the bank employees. In addition to this, each customer's ledger is also maintained, which contains the transactions specific to that customer. This ledger is visible to the customer and the bank. Now, the blockchain is also kind of an immutable ledger similar to the general ledger of the bank, which contains all transactions of all accounts. Transactions can be read or written to the blockchain, but cannot be modified or deleted once they are recorded. However, unlike the bank, all the data that is written to a public blockchain, like Bitcoin or Ethereum, is accessible to everyone, meaning that anyone can read or write transactions to these blockchains as long as they follow the rules of the network. Now, you must be thinking, if Bitcoin blockchain is a public ledger and anyone can write to it, then if I want to add 2000 Bitcoins to my wallet, I should be able to do so. Well, not quite. To understand this further, we have to understand how blockchain works. If we think about the bank example and where they keep the data, they have a bunch of servers and a large database behind the scenes which are controlled by them. Blockchain is quite different. Instead of some servers and database owned by a single company, a blockchain is a network comprised of a bunch of computers all around the world. Any person who has a powerful computer and a decent internet speed can install a blockchain software on their computer and become a participant of the blockchain network. There are different softwares for different blockchains. For example, Bitcoin Core for Bitcoin and Geth or Besu for Ethereum. Each of these computers who are participants in the blockchain network are called nodes. Each node, depending on its configuration, may download and maintain an entire copy of the blockchain ledger. This is why blockchain is also usually called a distributed ledger, because the copy of the ledger is distributed across multiple computers instead of being held by a single computer or a server cluster. So when any person tries to push a transaction to blockchain, it is broadcasted to a few nodes in the network. These nodes validate the transaction. If the transaction is valid, each node adds this transaction to its own mempool. A mempool is simply a place in each node's memory which holds valid transactions ready to be picked up and to be written to the blockchain. Each node has its very own mempool. After adding the transaction to its mempool, the transaction is propagated to other nodes in the network who repeat this process and the ripple effect continues. However, if an attempt for a fraudulent transaction is made, such as adding 2000 Bitcoins to a wallet out of nowhere, the nodes will mark the transaction as invalid because it's coming out of thin air and not from anyone's actual wallet. This invalid transaction will not be added to any node's mempool, nor will it be propagated to other nodes in the network, preventing the fraudulent transaction from being propagated in its crypt. Now, there are special types of nodes in the blockchain network called miners. Miners have an additional responsibility to write verified transactions to the blockchain. Once a transaction reaches a miner node, just like all the other nodes, it validates the transaction and adds the valid transaction to its mempool. Minor nodes then club the available transactions in their own mempool and attempt to write these transactions in the form of a block, where each block holds some data, which also includes a group of valid transactions. Now, whenever we record transactions on the blockchain, it is recorded in the form of these blocks. And these blocks are linked together in such a way that each block references the block before it. All these blocks are linked together to form a chain, which is unsurprisingly called blockchain. To summarize, a blockchain network consists of computers all around the world called nodes. They all run a blockchain software on them and keep a copy of the blockchain ledger. When someone pushes a transaction, nodes verify that transaction and push it to their own mempool and propagate to other nodes. Mempool is simply a place in every node's memory where all the verified transactions reside. Minor nodes are responsible to write transactions to the blockchain. These nodes pick transactions from their own mempool, group them together, and attempt to write them in the form of a block. Each block references the block before it by using a cryptographic hash, forming a chain called blockchain. So, in essence, a blockchain is still a distributed ledger. It's just written in the form of blocks linked together to form a chain. Now, imagine that a person takes a powerful computer and installs a hacked version of the blockchain client so that it is programmed to successfully validate a malicious transaction. So if this person tries to add 2000 bitcoins to a wallet out of nowhere, this hacked minor node will validate it and add it to the mempool. This minor node will pick up this transaction from its mempool and attempt to write a block. Now, the question is, how can this kind of malicious activity be prevented? This is prevented by something called a consensus mechanism. So, when any minor node collects transactions from their mempool, they cannot simply write a block right away. First, they have to create an actual block. The process of creating this block differs for different blockchains. For Bitcoin, proof of work is used, and for Ethereum, proof of stake is used. We will understand what these terms mean in a moment, but for now, let's assume that the minor node has created a block. This block then gets broadcasted to other nodes in the network, where they verify the block. These nodes verify that all the transactions in the block are valid, that the block is referencing the correct block in the blockchain, and whether the proof of work or proof of stake is properly done. This verification can be done by any node in the network. Then, if majority of the nodes agree that the block is valid, it reaches a network consensus. The block is then added to the blockchain and becomes a part of the immutable ledger. All the nodes update themselves with the latest ledger information, and the miner earns cryptocurrency for their effort. So when you hear someone saying that they're mining Bitcoin, their computers are actually doing all of this work and proposing blocks to earn Bitcoin. Now, let's understand what are these consensus mechanisms like proof of work and proof of stake, and why are they necessary. In Bitcoin blockchain and Ethereum 1.0, proof of work is used. Before proposing any block, the node needs to solve a complex mathematical puzzle. This solution takes significant computation power, so even if a malicious node proposes a malicious block, it has to do significant computational effort to produce this block, which will eventually be rejected by other nodes in the blockchain. If this mechanism was not present, the network would be easily spammed by malicious blocks. In Ethereum 2.0, proof of stake is used. In proof of stake, the node which proposes the block has to put some of their own cryptocurrency at stake. This is something like saying, hey, I'm proposing this valid block. I guarantee that it is valid, and to prove it, I'm willing to put my own 1 Ether at stake. The proposed block propagates through the network while other nodes validate it. If majority of the network finds the block invalid, this staked cryptocurrency is forfeited as a penalty. However, if the network finds the block as valid, the staked cryptocurrency stays with the node and it is also rewarded with some additional cryptocurrency. This process is set up to incentivize honest nodes while penalizing malicious nodes because their own crypto is at stake. In proof of stake mechanism, these nodes are not usually called minor nodes, rather they are called validators. There are also other different consensus mechanisms, but they are beyond the scope of this video. I hope you now have a clearer understanding of blockchain technology. But this was only a first step in the realm of blockchain. In my next video, we will get our hands dirty and write a very basic program or a smart contract that interacts with blockchain. If you have any questions or thoughts, drop them in the comments below. See you in the next video. Bis dann.